So let's review. What was type 1? Same degree over same degree. Degree 1 over degree 1. Degree 2 over degree 2. Degree 5 over degree 5. That's type 1. What is type 2? Do we remember what was type 2? Higher degree in the denominator. Awesome. Exactly. So that was type 2. What is type 3? Type 3 is a function that has a higher degree at the top, but exactly by how much?
Plus 1.
By 1. So here's an example. X squared plus x minus 6 over x minus 3. Is this type 3? What is the degree at the top? 2. What is the degree in the denominator? Perfect. So this is indeed type 3. What is different here from the other cases? Very little. Just one idea. It does not have a horizontal asymptote. That's the only difference. It will have a slant asymptote instead of a horizontal. Not a horizontal. It will have a slant, which can be this, which means the end behavior will be negative infinity to positive infinity, or could be this, which means positive to negative. That's the only difference from the rest. Okay? So let's take a look. What will be the first step before we identify the domain, before we start the table? What will be the first step here that I will definitely have to perform? Before that, and before the domain, correct. Yes, we can get the table started if you want, that's fine.
Well, we already know which type it is.
Yes, perfect. Since I put the equal symbol, exactly what do you think I'm referring to? What do you think we should do? If you're given this expression and you're not asked to do anything, what will common sense say to you?
0.
You cannot change it. It's an expression.
Oh, wait.
So if I'm given this expression, no comments whatsoever, I'm given this. What do you think? What would you think of doing?
Domain.
Correct. Domain. And what else? I can simplify in this shape. I cannot simplify terms. I cannot simplify x with x or 3 with 6. Not yet. Yes, domain is perfect. What else?
X-Intercepts.
Correct. That's also true. But I have to factor the top. If I don't factor the top, I will not know whether there is a hole in the graph or not. Right? So if I'm given this, the only thing that I would say is x not equal 3, obviously, and factor the top. There is nothing else if I'm not told anything, right? So if I'm given this, I will definitely factor the top immediately and think of the domain. There is nothing else that I could, unless I'm told, solve the equation, graph, find this, find that. If I'm not told anything, this is what I would do. So how will I factor the top?
X minus 3x.
Careful. Very good. Perfect. Thank you very much. Okay, so now I can get the table started. Oops. So what is the domain? What type of function is it? It cannot be all real numbers because it's rational, and we just said a second ago that x cannot be 3 because the denominator cannot be 0, right? We know that. We've experienced this before in solving rational equations. You remember in chapter 1? Okay, so then the domain is negative infinity to infinity, of course, except 3. X minus 3 cannot be 0, therefore x cannot be 3. Very good. Okay, so then is x minus 3 going away with the factor from the top? Because we know what happens. We did that last time. If a factor goes away from top and bottom, what will the function do over there? Well, what happens at that point? Exactly. Awesome. Yes. But x minus 3 does not go away with the factor from the top. So definitely there is no hole in the graph. Agreed? So then what does x equals 3 represent? Yes, it's A. It's A. Let's go back. Let's go back to last time. So when x, for example, in this problem, x happened to not equal to 3, what did we write?
It's a VA.
It's a VA, indeed. So at that point, the function has a vertical asymptote. Very good. VA, vertical asymptote. Once we conclude that, what happens left and right? For sure, if it's a vertical asymptote. What do we know to put here, left and right? Once I say it's a vertical asymptote, I have to write, awesome, thank you, infinities. What I don't know, however, is the sign of that infinity. I'm going to use two numbers as close as possible to 3. But as you see, I do not put them in the table because I'm not going to plot them. They're only a tool to help us find the sign of these infinities. So let's put 2.9 in here. I don't calculate anything. I just want the sign from you. When I replace x by 2.9, what would be the sign of this expression? Agreed? Good. What will be the sign of this expression? Perfect. What will be the sign of this expression? Perfect. So then the signs here will give us the sign of the infinity. If the top is positive and the bottom is negative, what will be the sign of this infinity? Awesome. Let's plug in the other one, 3.1. With 3.1, what is the sign of this? Perfect. With 3.1, what is the sign of this? With 3.1, what is the sign of this? So what is the sign on the right-hand side of the asymptote? Awesome. Very good. Okay, so let's plug in 0. 0, 0, negative 6, 0, negative 3. Negative 6 over negative 3. Awesome. Now we want to find the x-intercept. So x-intercepts are determined when f of x equals. Perfect. Awesome. So then I have x plus 3 times x minus 2 divided by x minus 3 equals 0, or 0 over 1. So therefore, what happens next? When is a fraction 0? You can think in two terms. A fraction is 0 only if the top is 0. A fraction is undefined when the denominator is 0. So I'm asking myself, when is this fraction 0? Or just cross multiply, whatever is easier for you. So when will this be 0? When x is okay, let's cross multiply. Let's write it. Nothing wrong with that. So what will you tell me to write? Say it again. If the denominator is 0, we are in big trouble. When I want to determine the values of of x that make a fraction 0, the numerator has to be 0. So one more time. A divided by b is 0 only if a is 0. There is no other way. A divided by b is undefined if b is 0. Fraction is 0 if the top is 0. What is the top of this fraction? Times x minus 2 equals 0. So then there are two options. X equals awesome and exactly. There's nothing else. Very good. The numerator is 0 when x is negative 3 and x is 2. So I put those in the table. Negative 3 and 2. Be very careful where you put them. I kind of extended myself here, so I'm going to write 0 and 0. Any questions? Any questions? Okay. So finally, we know that this function will not have, let's write this down, type 3 does not have a horizontal asymptote, comma, but slant asymptote. Okay, so let's take a look at x squared plus x minus 6 divided by x minus 3. I will use whatever you decide, either synthetic division or long division, to find the quotient plus the remainder over the divisor. And you can ask why, and in a minute I'll tell you why we divide. Now, question, can I use long division here? Can I use long division? Perfect. Can I use synthetic division? Perfect. Which one would you like?
Long division.
Long division. Good. Are they in descending order?
Yes.
Perfect. Any missing term from the top? Very good. X squared plus x minus 6 and x minus 3. Remember, at the top, we do not lie. You know what I mean? I'm just trying to trigger your memory. So what times x is x squared? Perfect. We go back and distribute. X times x. What do I write? Awesome, thank you. X times negative 3. It's negative 3x, but I have to change the sign. Very good. Perform the operations I see and bring down the next in line. X times what is 4x? Sign. Careful, we never lie at the top. Very good, awesome. So then 4 times x. We subtract. 4 times negative 3. It's negative 12, but we have to write positive 12. So what goes in the box? Perfect. So now can anyone dictate the final answer of this division? Plus, yes, the divisor. Perfect. We are only interested in this piece. This is y equals x plus 4, the slant asymptote. So the slant asymptote behaves like a horizontal asymptote in the sense that it will always give us, like the horizontal one, end behavior of the function. If there is a horizontal asymptote of 1, what is the end behavior of the function to the left at negative infinity? 1. What is the end behavior at x approaches infinity? Also 1. The same thing here. But this time, this is not a horizontal line, but a slant. Does it have a positive slope? If yes, it looks like this. If it has a negative slope, if yes, it looks like this. Which one is it? Positive. So this line has a positive slope, and the function will follow it. What is the end behavior of the function then? What's here? Infinity, 2. That's it. That's all I need to add. So negative infinity to positive infinity, and y equals x plus 4 slant asymptote. I think that if you understand the table and you understand how we summarize the information in the table, this should not take more than 3 to 4 minutes. I don't want you to spend too much time on this. I want you to understand the graph and be able to do word problems, and we'll have at least 2 problems in a minute. But I don't want you to spend too much time on this and finding too many points. There is no need for that. Okay, and we'll practice some more, of course. So when I graph a function with asymptotes, what do I have to graph first? Yes?
Just kidding.
I'm sure you know. When we graph a function with asymptotes, we have to start by graphing the asymptotes first, of course. They're not part of the graph, but they have to be graphed. So how many asymptotes does this function have? 2. Perfect. What is the first one I should graph? It doesn't matter which one would you want to graph first. X equals 3. Perfect. Here it is. Awesome. Thank you very much. X equals 3 is the first asymptote. Here's the second one. But here I have to find 2 points. And remember the x and y intercepts. When x is 0, how much is y? When x is 0, y is? Careful. When x is 0, y is 4. When y is 0, this is 0 now, 4 plus what is 0? Perfect. So now this is the slant asymptote. So y equals x plus 4. Okay, now let's try and make sense of the information we have here. Let's see if it works. Ready? Okay. So I have to plot this point -3, 0. No problem. I did. I have to plot this point 0, 2. No problem. I did. And then 2, 0. Now let's see what we see here. Let's discuss this. It's coming from -infinity, has to approach the asymptote. It crosses at -3, 0. It crosses at 0, 2. It crosses at 2, 0, and comes towards -infinity. One more time. From -infinity up to -3, 0, up to 0, 2, down here to 2, 0, and down to -infinity. That's it. So that's that part. Now, with algebra, we do not know for sure whether it turns here, up here, or if it turns on the y-axis, or it goes further up. I don't know. That's all I want you to do. If you're interested in solving this problem, as I said, I promise it will be an extra credit to choose from. Okay, so we'll see in a moment because we have to find the maximum. Now, what happens here? How can a function connect infinities? It won't. It does this. That's how the function connects infinities, right? So this little piece on the right-hand side, it's coming from positive infinity and going towards positive infinity. It has to have a minimum. There is no straight line between infinity and infinity. There is no such thing. So it has to do this. And that's the graph. That's the graph of f of x equals x squared plus x minus 6 over x minus 3. Let's graph it now with the graphing calculator. Once we understand the graph, the rest should be a piece of cake. So in y equals, so in parentheses, do not forget, whenever you graph, you check with the graphing calculator, you must, rational functions, you must put the numerator in parentheses and the denominator in parentheses, otherwise the calculator will graph whatever he, she, it wants. Okay, so x squared plus x minus 6 and divide by, in parentheses, x minus 3. What other function do I have to put in the graphing calculator because the calculator doesn't know it?
Asymptote.
Exactly. Y equals what? Indeed. Of course. Very good. So now let's say I already graphed the function. I don't know how high it goes or how low it goes, so you can choose the standard viewing window for now. Although we have that piece, well, hopefully we have the top part. If not, if it's not in the table, that in the viewing window, then we have to adjust the whole thing. Okay, so obviously I don't see this part, and there is a vertical asymptote at x equals 3 that the calculator or the software does not present. So I go to the viewing window, and I have to adjust the maximum x. Let's say I'm going to say 20. We'll see in a moment, with a scale of 4. And I have to adjust the y maximum. I'm going to put 30 with a scale of 5. And let's see now. I don't know if this is good enough. Well, yep, it's more than enough. So we see the slant asymptote. We see that the function gets closer and closer to it, as expected. That's why it's called a vertical asymptote or slant asymptote or horizontal asymptote. That's the behavior of the function. We will follow that. And we can determine the maximum. As you see, the maximum is to the right-hand side of the y-axis. It does not turn before. It does not turn on the y-axis. It turns to the right-hand side. So I'm going to determine this maximum with second and calc. And maximum is 4. And I'm going to say maximum when x is 0 is the left bound. Oh, it does that all the time. I'm not sure why. So I want maximum. Okay, left bound 0. Right bound, I'm going to say this was 1. It was 2. Right bound 2. And just give me the maximum. And as you see, the maximum is to the right-hand side of the y-axis. It's at 0.55, 2.1. 0.55 and 2.1. So it's right here. 0.55, 2.1. And the other one is the minimum. So obviously it's between 4 and 6. So second and calc. And the minimum is 3. Between 4 and 6, and enter. So it gives us as minimum as at 5.4, 11.9. 5.4, 11.9. So let me show you what I wrote. I did not erase anything. These were the 3 possible options. I only pointed that this is the correct one, and that's good enough. And I showed that this is the minimum, 5.4, 11.9, and I put these 2 numbers in the table. This is a local minimum. This is a local maximum. And that's the end of rational functions, and not before we look at some word problems. Now, I'm sure you remember the type of applications we looked at for quadratic functions. What did we do? We threw a ball up in the air, and the trajectory was a quadratic function, right, with a maximum. What else we did? We were given cost functions, profit functions, and so on and so forth. Just simple, I would say, simple type of applications. The applications using rational functions are way more sophisticated. So let's take a look. So let me find my page over here. Way more sophisticated, way more difficult to develop a model that uses a rational function, way more work. However, the most interesting applications in this class will be in chapter 4, when we talk about two new functions, exponential and log. So let's take a look at 3.5. Okay, so here it is. I don't know what to do with the sun. I'm so sorry. I'm sure it will be difficult, but if you have your book or... Okay, so here it is. The function blah, 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 right here, given to us, models the pH level f of x of the human mouth. So this is way more difficult, more sophisticated application. Models the pH level of the human mouth X minutes after a person eats food containing sugar. The graph of the function is shown here. So here's the first question I have for you, because this problem like this will be on the test. So what type of function is this? Say it again. Okay. What type of functions are we talking about?
One.
Okay. Yes, type 1, obviously, because it's degree, same degree over same degree. Exactly. Thank you. So in this chapter, we talked about polynomial, and this is rational. It's a ratio of two polynomials. Perfect. So it is type 1 because it has same degree over same degree. Does it have a horizontal asymptote? Type 1. Does type 1 have a horizontal asymptote? Yes. What is it? How do I determine it? It has a horizontal asymptote. Type 1 has, type 2 has. Type 3. Type 3 has a, say it again. It's the leading coefficient over the leading coefficient. And for type 2 is? Awesome. And for type 3? There is none. Awesome. Excellent. Thank you. So let's take a look at this function again and determine the horizontal asymptote. So what is the horizontal asymptote of this function? Say it again.
6.5.
6.5 over 1, which is 6.5. Leading coefficient over leading coefficient because it's type 1. Agreed? Good. Let's take a look at the graph. Is there a horizontal asymptote of 6.5? Yes, there is. Okay, let's analyze the graph. So it appears that at time t equals 0, the function starts at 6.5. Then it comes down to a point 6 minutes later. And then eventually, look, it takes 66 minutes, 60 minutes, an hour, when the pH level gets back to normal. So it starts at normal. I take a piece of sugar, candy, whatever. 6 minutes later, the pH level in the mouth drops to a value, and then eventually gets closer and closer. It takes 60 minutes, an hour, till it gets back to normal. So here's the question. Here we have A through E questions. Use the graph to obtain a reasonable estimate to the nearest tenth of the pH level of the human mouth 42 minutes after a person eats food containing sugar. So here's 42. What will you say roughly? 6. Yes, it appears to be 6. So after we swallow something with sugar in it, about 42 minutes later, it gets back from 6.5 down to whatever, and then in 42 minutes later, it gets back to 6. Okay. After eating sugar, when is the pH level the lowest? Yes, 6 minutes. Okay, after that. Perfect. According to the graph, what is the normal pH level of the human mouth? 6.5, according to this. What is the equation of the horizontal asymptote associated with this function before we even read that? Y equals 6.5. Okay. Use the graph to describe what happens to the pH level during the first hour. And also, we see that at 6 minutes later, what will I say? Maybe 4.6, 4.7, maybe 4.8. It's hard to read. But 6 minutes later, it drops to this value. And then slowly increasing. And about 60 minutes later, it approaches the normal value. Any questions? As you see, this is a way more sophisticated, way more difficult model to work with than the quadratic, throwing a ball up in the air and following the trajectory. Okay, perfect. Let's look at the next one. So here, a drug is injected into a patient, and the concentration of the drug in the bloodstream is monitored. Look how sophisticated this is. This is not a simple quadratic at all. So what type of function is it? Yes, it is type 2, and it is rational. What is the horizontal asymptote for type 2? Right, because we hope There are people who have to be on a certain medication for the rest of their life. But other than when we get sick, or let's say you have to take an antibiotic or something like that for short term, we hope that after we take the medicine for whatever, eventually the medicine in our bloodstream will go away. So the concentration approaches zero. So as you see, that's why this model, it's one of the reasons why this model has a horizontal asymptote of 0, because we hope that in the long run, it comes out of our system. Okay, let's see what they want. Use the graph to obtain a reasonable estimate of the drug's concentration after 3 hours. I have to look at this carefully because it says from 0 to 10 with a scale of 1, and from 0 to 3 with a scale of 1. 0 to 3, 1, 1, 1. So after 3 hours, 1, 2, 3, I would say is roughly 1.5. The concentration is 1.5 of the medicine in the bloodstream. Use the functions equation displayed in the voice balloon, which is this and this, by the graph to determine the drug's concentration after 3 hours. We determine from the graph 1.5. Let's see. How much is 5 times 3? 15. And 3 squared plus 1? 10. How much is 15 over 10? 1.5, as we expected. Use the functions equation to find the horizontal asymptote for the graph. What is the horizontal asymptote for this graph? Y equals 0. And we can go on forever with all sorts of other applications. As you see, this is way more involving that simple quadratic function. Last section for test 2. Some of you, 1 or 2, came in late. So test 2 is scheduled for next Monday. So it covers 2.5 through 2.8 and everything from chapter 3. And there is one final section that is 3.6. One of your colleagues requested an extension for test 1 homework. I will grant it till tomorrow night, but I would like to put this behind us, because if we are still working on test, yes. So if we're still working on test 1, then we haven't accomplished much in test 2, the material for test 2. So I'm really hoping that you're going to finish. Okay. So the last section that we have to talk about, yes, Jesse, go ahead. Paris, go ahead. Any questions? Okay, very good. You're a very good influence. So I also gave out a handout, and if we have time, we start with this today. But I'm kindly asking you to work on this as much as possible between now. Oh, yes, I have one more. Between now and Wednesday, because if you, yes, sorry, I forgot. So, because if you don't do anything between, that's very important. I don't know why. I don't know why. That's so important. Yes, oh, yes, I'm sorry. That was a question that I got a minute ago, and I have to look at my schedule. I would be more than happy to. Okay, so 3.6 is the last section before test 2, and it deals with polynomial and rational inequalities. Polynomial and rational inequalities. I'm going to make 2 inequalities up, and then we can choose other problems from the book. So here's one. X in front, negative x plus 1, x minus 4, and x plus 2. Let's say greater than or equal to 0. So what is this? So the right-hand side, or the symbol, clearly says it's an inequality. It's not an equation. We know that. So now the second thing is, let's look to the left-hand side. What do we see here? What is this?
Polynomial.
Awesome. Excellent. So what degree? 4. We have x times negative x times x times x must be x to the 4th power, because there are four factors with degree 1. So x times x times x times x, copy the base, add the exponents. Very good. Degree 4. So when will this be 0? When x is? Awesome. When will this be 0? When x is?
1.
1. Very good. Awesome. When will this be 0? Awesome. When will this be 0? Good. Awesome. So what did we do? First of all, we established what it is. We know it's an inequality. We know it's a polynomial. We know it's a polynomial inequality of degree 4. We accept that statement? Very good. So let's take a look how to address this. And this is the method I recommend. And of course, I accept other methods. So let's create a table in which x at the top is only the variable in the problem. X at the top is none of the factors we see. So x is between negative infinity and infinity. The next row is, I will present each and every factor, but this is the first factor, this is the second factor, this is the third factor, this is the fourth factor. All of them will be one under the other, and they will have their own row. So x is the first factor. Negative x plus 1 is the next factor. X minus 4 is the next factor. X plus 2 is the last factor. And what do you think the last row will represent? The whole thing, not the sum. It's the product, right? The whole thing. Of course, I don't have enough room, so I'm going to just write the product. By the product, I mean all this. This is the product. This whole thing is the product. Okay. You gave me all the zeros, all the x-intercepts, if you want, for each and every one of them. These are the only numbers that I will put in the top of the table. But I need to put them in ascending order from left to right. Which one will be going into the table first? Correct. So this is done. Next one. Awesome. This is done. Next one. Awesome. And then 4. Perfect. Each row will have a 0 under the corresponding number. So where will I have the 0 for x? Under
0.
Awesome. Where will I have the 0 for negative x plus 1?
1.
Of course. Where will I have the 0 for x minus 4?
4.
Awesome. Makes sense. And where will I have the 0 for x plus 2? Very good. Now, here's a key question. What happens to the product when x is negative 2, 0, 1, or 4? Of course. If any of the factors is 0, the product will always be 0. It's sufficient for one of them to be 0 for the whole thing to be 0. Agreed? Because by the zero product principle. Awesome. Thank you. Okay. So now x negative x plus 1, x minus 4, and x plus 2 are all what type of functions?
Linear.
Awesome. So then they can only look like this, from negative infinity to positive infinity, which is the end behavior, or they can look like this, from positive to negative. First one, how does it look? From negative to positive or from positive to negative?
Horizontal.
Say it again.
Horizontal.
Horizontal means y equals 5.
Oh, it's going to be 1 over, is it?
So we're only talking right now about x.
Mm-hmm.
So does it look like this with a positive slope, which is negative 0 positive, or positive 0 negative? Do you all agree? Yes? Very good. I'm sorry? The slope is positive. We only have 2 types of lines. This line with a positive slope and this line with a negative slope. So it's negative and then positive. What can you say about the other one? The slope is negative. But what I'm interested in is if it comes from negative infinity to positive or if it's going from positive to negative. Of course. What about x minus 4?
Okay.
Very good. Because it has a positive leading coefficient or positive slope. What about the last one? Just be careful because I arranged all of them in descending order, otherwise I may make a mistake. So that's very important. So what about x plus 2? From? Awesome, thank you. So let me ask, is anyone confused about this?
Yep.
Okay. Do you remember when we talked about polynomials? We said that any odd degree polynomial has the end behavior of a linear function. If it has positive leading coefficient, it looks like this. If it has negative leading coefficient, it looks like this. Right?
Mm-hmm.
Or you can say, I don't want to think in those terms, just plug in a number. Plug in negative 2, you get negative. Plug in 4, you get positive. Here's the second one. Plug in negative 2, you get positive. Plug in on the other side of 0, plug in 4, you get negative. Plug in on this side, negative 5. Negative. Plug in on this side, 10. Positive. So if you don't want to think in terms of this or this, which is the easiest in my opinion, just plug in numbers. Is that okay? Do we know how to graph this function? Where does it cross the x-axis? Where it's 0, at 4. So if we want to graph x minus 4, how will I graph? Here's x minus 4. Here's x minus 4. It crosses at 4. It's below the x-axis. It's negative before it's 0. And it's positive above. That's what I put in the chart. Negative, 0, positive. How will I graph negative x plus 1? Let's take a look at negative x plus 1. Negative x plus 1. We know I use this because we know how to graph linear functions. Why not use it? So if you look in the chart, before x equals negative 1 is positive. After negative 1, negative. So thinking in terms of the linear function, I said, okay, well, this is a linear function with a positive slope. It must be negative and then 0 and then positive, because the positive slope makes it look like this. But this one looks like this. It's coming from positive and going to negative. Positive and going to negative. What about this one? Positive slope. It's coming from negative going to positive. Negative crosses the x-axis, positive. What about this? Same thing. Because it crosses at negative 2, it's negative before it crosses the x-axis, and it's positive after that. It's all based on the end behavior from polynomials. But again, if you say, no, I would like to plug in numbers, then plug in numbers. You plug in a number before the 0, and you'll see it's negative. You plug in a number after 0, you'll get positive. And for all of them. Is this better?
So it descends from like positive to negative because you would need like a positive 2 in order to get.
For the second one?
Yeah.
No. Just plug in between negative infinity and its 0, which is 1. Plug in any number, negative 10. Negative 10 with minus in front is 10. 10 plus 1 is positive. Or you just think in terms of the end behavior, which I think it's easier. You don't have to plug in numbers, but it doesn't matter. Is this somewhat better? Are you with me? Any questions? Better? Okay, so now I see 1, 2, 3, 4, 5 subintervals. So I'm looking at the first subinterval, and I say this. The first factor is negative. The second one is positive. The third one is negative. And the last one is negative. what will the sign of this product be? And do not count, exactly, do not count the positives. They don't do anything. So this is indeed negative because there are 3 negatives. Awesome. In the next subinterval, I have a negative, positive, negative, positive. I shouldn't even count the positives. I have 2 negatives. What will be the sign of the whole product? The first one is negative, the second one is positive, the next one is negative, the next one is positive. What will be the sign? Because there are 2 negatives. Okay, in the next subinterval, I see 1 negative.
Oh, okay, hang on, because you do that. Okay, okay.
So what is the sign of the product? Very good. Are you with me? Yes? So the question is, the first one is positive, the next one is positive, this one is negative, and this one is positive. Positive, 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 negative, positive. What will be the sign of the outcome?
Negative.
That's why we wrote negative here. Then I have 2 negatives. What is the sign of the outcome? And I only have 1 negative on the last subinterval. What is the sign of the outcome? Perfect. So now finally, I go back and ask myself, what will I choose? What sign is greater than or equal to 0? And that's the one I choose. And the reason we only have 2 signs. Which one is greater than or equal to 0? Positive. So then I look and see, is this product ever positive? For which x values? So I will write x in the interval.
Wait a minute.
So the product is to be greater than or equal to 0 because it says greater than, which means positive, correct? Is positive greater than or equal to 0 or negative greater than or equal to 0? Which one? Positive, correct? So I'm asked to find x such that this product is greater than or equal to 0. What sign do I pick for the product so that it's greater than or equal to 0? Positive, correct? So then I look at the table at the bottom last row, and I'm asking myself, is this product ever positive in this interval, in this interval? But I'm asked to choose x that makes the product positive. So then x is in the interval. What interval? Since we have the equal symbol, we will also choose the zeros. So -2, 0, union 1, 4. What does this mean? It means that if we pick x values between these 2 or these 2, this entire product is guaranteed to be positive. But what if I pick between -∞ and -2, or between 0 and 1, or between 4 and infinity? What will happen then? The entire product will not be positive or 0. It will be negative. Because that's what the result is. It says negative. So if I pick this or this or this, I will get a negative number.
Negative y.
I'm sorry?
Why is it negative? Because there's more negatives?
Because 3 negatives will give us a negative when we multiply them.
All right. Explain why, because I don't think you explained why before you just started going down this list.
Why we get these symbols?
Yeah.
Okay. Multiply for me a negative by a positive by a negative by a negative. 3 negatives. What will your sign will be?
Negative.
Multiply 2 negatives for me.
Positive.
Multiply 1 negative.
Negative.
Multiply
I get
2
that now.
negatives. And multiply 1 negative.
Okay.
So now I have to choose according to the symbol. I have not taken this symbol into account all this time. I'm done with the table. I know exactly when the product is positive and when it's negative, and now I choose what I'm asked to choose. And I'm asked to choose the positive. So that's why I say x must be between these 2 intervals where the product result is positive because of this symbol. But if I'm asked the opposite one, then I will be choosing 1, 2, 3. Why? Because the product is negative in 1, 2, 3. Let's look at another example. I think it's going to become very self-explanatory, very easy. With the second example, Joseph?
I'm sorry, so in order for like it to be positive, x has to be equal to anything between like -2 and 0 or 1 and 4? Or for it to be
If you
greater than 0?
if you pick x over there in these
Oh,
two,
yeah.
the product is guaranteed to be 0 or positive.
Okay.
If you pick between -∞ and -2, union 0, 1, union 4 to infinity, the product is guaranteed to be negative.
All right, yeah, thank you. Sorry.
Yeah, no, that's good. That's okay. Anything that stirs up comments and discussion is good. Anything. Okay, let's invent another one. Any preference? Okay, so I'm going to choose x plus 2, -2x plus 4, x minus 1. Let's say this time less than or equal to 0. How many factors we see? What would be the 0 for this one? I need to identify them before I start the table. Awesome. What is the 0 for this one? Very good. Awesome. What is the 0 for this one? Perfect. So each factor, each number will be at the top of the table. First row is always the values of the variable. Second row is the first factor. Next row is the next factor. And what do you think will be the last one at the top? Exactly. The product of all of the above. We established that 3 numbers have to be in the table. Can you give them to me in ascending order? Yes? Yes? Perfect. So now there is a 0 for, yes, Stephen, any questions?
Yeah.
So x plus 2, where does it have a 0? Awesome. Where does this one have a 0? Perfect, awesome. Where does this one have a 0? I was hoping that you would just find this as a little puzzle. What would happen to the product if any of the factors is 0? Exactly. By the 0 product principle, at any of those numbers, the whole product will be 0. Is that clear with everyone? Okay, so now give me the sequence of signs for each factor. Right. Do you all agree? Because this is a linear function with a positive slope, the end behavior must be negative infinity to positive infinity. We agree? Okay, what about the second one? Right, because the leading coefficient or the slope is negative, so the function must look like this if I want to graph it. But I don't want to graph it. I just want to identify the sign. And the last one? Yes. Is this better already? Is this better? How we determine these symbols?
Mm-hmm.
Perfect. So now please multiply these 3 numbers and tell me what will be the sign of the outcome for the first subinterval. Do you all agree with positive on the first subinterval? What about the second subinterval? Perfect. What about the third subinterval? I agree. And what about the last subinterval? Perfect. Is this clear with everyone? Yes? Better? Okay. The first example is always a little bit more, looks more complicated, more difficult. It takes more time. It's always the case. Okay, so now look at this. This tells me what to choose. Which sign will I choose now? Do we all agree with negative? Because a negative number is less than or equal to 0. Right? So now, is the product ever negative? Yes. I see the product negative here, and I see it negative here. So then I will choose the corresponding x values that make the product negative. What will that be?
-2, 1. Union. 2.
Do we all agree? I have to pick exactly what creates a negative product. What creates a negative product is any x value between -1 and 1, and any x value between 2 and infinity. Better? Is that a yes? Is that a maybe? Not for you. Okay, so final topic, rational inequalities. Identical with this, really. So x minus 1, negative x plus 4 divided by x plus 1. You want greater than or less than?
Greater than.
Very good. It doesn't have to be equal to. I put equal to, but we can just stick with just greater than. Doesn't matter. Let's put just greater than this time. No equal symbol. How many factors we see? Good. X, for this one, x will be, very good. For this one, x will be, very good, awesome. And for this one, x will be, very good. I need to determine them on the side, so I make sure that I put them in ascending order, because if I mess that up, the whole thing is messed up. X is the variable in the problem. X minus 1 will be the next in line. Negative x plus 4, next in line. Of course, x plus 1. And of course, I ran out of room, so I'm going to write ratio this time. It's no longer a product, but it's a ratio. And we have from negative infinity to infinity. And now please dictate from left to right the numbers in ascending order.